everybody, we're back for section 5, water underground. Today we were looking at how does water move through underground layers of soil and rock, and how do people obtain water from an aquifer. All right, here we go. When you were a little child, did you ever dig a hole in the ground hoping to find buried treasure? You probably never found a trunk full of gold, but there was a certain kind of treasure hidden underground. If you had dug past the tangled grass roots and small stones, the bottom of your hole would have filled with water. You would have struck groundwater. In the days before public water systems, water underground was truly a hidden treasure. Today, many people still rely on the water underground to meet their water needs. So how does water move underground? Where does this underground water come from? Like the water in rivers, lakes, and glaciers, it comes from precipitation. Recall that precipitation can evaporate, run off the surface, or soak into the ground. If water soaks into the ground, it trickles downward, following the pull of gravity. If you pour water into a glass full of pebbles, the water trickles down through the pebbles until it reaches the bottom of the glass, when the water begins to fill up the space between the pebbles. In the same way, water underground trickles down between particles of soil and through cracks and spaces in layers of rock. Effects of different materials. Different types of rocks and soils have different size spaces or pores between their particles, as shown in figure 2.1. So 2.1, we can see we have all these different layers here. We'll get to that. Okay, the size of the pores determine how easily water moves through rock and soil. If the pores are connected, this too affects water movement. Because they have large and connected pores, materials such as sand and gravel allow water to pass through or permeate. They are thus known as permeable materials. As water soaks down through a permeable rock and soil, it eventually reaches layers of material they cannot pass through. These materials have few or no pores or cracks. Two examples are clay and granite. Clay and granite are impermeable, which means that water cannot pass through them easily. So we have water zones. Once water reaches an impermeable layer, it is trapped. It can not soak any deeper. Instead, the water begins to fill up the spaces above the impermeable ground. This area of permeable rock or soil that is totally filled or saturated with water is called the saturated zone. The top of the saturated zone is the water table. If you know the depth of the water table in your area, you can tell how deep you must dig to reach groundwater. Soil and rock layers above the water table contain some moisture too, but here the pores contain air as well as water. They are not saturated. Therefore, the layer of rocks and soil above the water table is called an unsaturated zone. So, let's look at these, okay? We have unconnected pores and we have solid rock, just like granite. So this is our impermeable layer. It cannot go through this layer here, okay? And then we have a saturated zone. Okay, this means there's no air holes, there's no water, there's only water here. So this is like our water table. Oops, that didn't get very dark. Okay, and then up here we have our unsaturated zone. The water goes through all this area to where it's stored in the bottom. Okay, all right. Let's go on. Bringing up groundwater. Suppose you live far from the city, town, or body of fresh water. How could you reach groundwater to use for your daily needs? You may be in luck. The water table in your area might only be a few meters underground. In fact, some places in the water table actually meets the surface. Springs can form as groundwater bubbles or flows out of the cracks of the rock. A short distance away, the water table may be deep underground. So aquifers, any underground layer of permeable rock or sediment that holds water is called an aquifer. Aquifers can range in size from small underground patches of permeable material to areas the size of several states. The huge High Plains aquifer lies beneath the plains of the Midwest, from South Dakota to Texas. Millions of people obtain drinking water from this ground storehouse. This aquifer also provides waters for crops and livestock. Do you picture groundwater as large, still pools beneath Earth's surface? In fact, the water is moving, seeping through layers of rock. The rate of movement depends largely on the slope of the aquifer and the permeability of the rocks. Groundwater in some aquifers move only a few centimeters a day. At that rate, the water moves only about 10 meters a year. Groundwater may travel hundreds of kilometers and stay in the aquifer for thousands of years before coming to the surface again. Okay, this math analyzing data, this pie chart here, you need to be able to read this, and you'll be answering these questions as part of your homework tonight. Okay, so let's look at this. Artesian wells. Water rises when a rock above an aquifer is punched. So that's right there. This is the aquifer, and this is artesian well. Okay, here's a well. A channel dug into the aquifer provides a supply of water. So again, this is the aquifer. Okay, a dry well is when the level of the aquifer drops and a well can run dry, so it doesn't have a supply of water there anymore. Okay, so groundwater that flows to the surface is called a spring. So we could have an aquifer right here, and it comes out as a spring. Okay, wells. The depth above water table can vary greatly over a small area. Its level may vary as well. Generally, the level of a water table follows the shape of underground rock layers, as shown in Figure 22, but it can rise during heavy rains or snow melts, and then fall in times of dry weather. So what do you do if the depth and level of the water table in your area is far underground? You can bring the water to the surface. Since ancient times, people have brought groundwater to the surface for drinking and other everyday uses. People can obtain groundwater from an aquifer by drilling a well below the water table. Locate the well in the center of Figure 22. So these are the wells here. Okay, these are the wells. Okay. All right. Because the bottom of the well is in the saturated zone, the well contains water. Notice the level at the bottom of the dry well in diagram. Because this well does not reach the water table, water cannot come from it. So we already talked about these two wells right here, and this is the well that can get the water. Correct? Okay. All right. Using pumps. Long ago, people dug wells by hand. They lined the sides of the well with brick and stone to keep the walls from collapsing. To bring up the water, they lowered and raised a bucket. People may have used simple pumps like the one shown in Figure 23, this old sound pump, right? To bring up water. Today, however, most wells are dug with well drilling equipment. Mechanical pumps bring up the groundwater. Pumping water out of an aquifer lowers the water level near the well. If too much water is pumped out too fast, a well may run dry. The owners of the well will have to dig deeper to reach the lowest water table or wait for rainfall to refill the aquifer. New water that enters the aquifer from the surface is called recharge. Relying on pressure. Now you know how to bring groundwater to the surface. But what if it didn't work? You might not be out of luck. You might be able to drill an artesian well. In an artesian well, water rises because of pressure within the aquifer. Looking back at 22 and locate the artesian well. In some aquifers, groundwater becomes trapped between two layers of impermeable rock or sediment. The water is under great pressure from the weight of the rocks above, and the top layer of the rock is punctured. The pressure sends water spraying up through the hole. No pump is necessary. In an artesian well, pressure does the job. So if you notice, this was our artesian well right here. Okay. Okay. Springs and geysers. Sometimes underground comes to the surface through natural processes. You can read that places where underground bubbles or flows out of cracks in a rock are called springs. Most springs contain water at normal temperatures. Otherwise, like in Figure 24, 4. Contain water that is warmed by the hot rocks deep below the surface. The heat water bubbles to the surface in hot springs. Okay, so you can see this is a nice hot spring, and there are hot springs located around the United States. In some areas, you might see a fountain of boiling hot water and white steam bursting into the air. This is called a geyser. Sorry about that. Okay, this is a geyser, a type of hot spring from which the water periodically erupts. The word geyser comes from the Icelandic word geyser, which means gusher. A geyser forms when very hot water that has been circulating deep underground begins to rise through a narrow passage in the rock. Heated gas and bubbles of steam are forced up these passages by the pressure of the hot water boiling below. Just as pressure builds up in a partially blocked water pipe, the pressure within these narrow openings in the rock increases. Finally, the gases, steam, and hot water erupt high into the air. All right, homework today is actually this math analyzing data here, plus section 5 assessment. Okay, you will also have a study guide because we'll have a test the following week after this, and so this is also your study guide that you will put online. You'll enter the answers online. All right, I will see you next time. Have a good day. Bye.